That's why it has to be tied from the bottom, right?
Mm-hmm.
And it goes to the inside.
Okay.
And that would be because the mass of the water resists change more than the bobber. So the mass of the water tries to go in a straight line, has more mass, more resistance to change, and builds up at the outside of the jar, forcing the bobber to the inside of the jar. I still want to know why they go to the inside and the outside.
Because the centrifugal force pulls it
Yeah,
towards
no,
you,
both
towards
are
the center.
hanging from the top.
Yeah, okay, so we're right.
Okay, so
But one is in water, yeah.
Is it
And
weighted?
the other one
Is
is
it
in
like
bobber,
air.
yeah.
Is
The
it like
bobber's
that?
full of water too.
the bobber, I think I put sand in.
Wait,
I can't remember.
Sledge.
This is air, and then, so when I spin it, in which, let's look at the red and white one. What has more mass per bobber unit? Water or bobber?
Water.
Water. So the water resists change more, and it's going in a straight line, and it's harder to change what it's doing. So basically the water pressure is building up on the outside of the jar, right? Forcing that air-filled bobber, less mass, easier to change what it's doing. To the inside, here, this bobber has more mass than bobber unit. See, it's made up units. Bobber unit of water. So the masses are different. The bobber has more resistance to change, so it has a harder time going in a
Talking
circle.
about so the difference in density, that in the water itself, that's what's causing the
No,
thing to move
the
in?
bobber's the.
Between the water and the bobber. The difference in density between the water and bobber.
One
Because
bobber is
mass.
less,
But I
and
understand.
one bobber is more dense.
Right.
The more dense
But I don't know
one
why-
goes toward the center.
Yeah.
Or, I'm sorry.
The more dense
One
one comes
more-
away
oh,
like the key.
Right. And just think, what we're interested in the component of density that we're interested in is mass. More mass, harder to change what it's doing, so the circle is bigger. Right? Less mass, easier to change what it's doing, so the circle is smaller. It changes direction more easily. Okay? So the accelerometer was really a helium balloon. When I pulled the box this way, the air had more mass than the helium, so the air got left behind, like the ocean and the tides, right? So the air built up, building up the air pressure and forcing the balloon to go where you didn't think it would. That's why it won't work if you tie something from the top. If you tie something from the top, it'll always do the opposite, which is really confusing. And I remember I tied a tennis ball, I think, to the top of the bus.
Well, if you tie something to the top, it's gravity pulling it down, therefore it has to be more dense than
Yes.
the substance it's in.
And it'll do the opposite of the helium. Right. All right, so now